Yo, 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 what up, homies? This video 11-2, Gay-Lussac's Law, Avogadro's Law, and Stoichiometry of gases. So, Gay-Lussac's Law of combining volumes. Okay, we had Gay-Lussac's Law before, but this is a little bit different one. Okay, now, Gay-Lussac basically said, well, if you have a constant temperature and pressure, okay, then the volumes of gaseous reactants and products can be expressed as ratios of small whole numbers. Okay, now, why is this cool? What does that actually mean? Turns out that these ratios of small whole numbers just happen to be the exact same thing as the coefficients in the balanced chemical equation. Okay, so in other words, remember, look at this equation here. Okay, H2 plus Cl2 gas will give you HCl, and it's a 1 to 1 to 2 ratio. Okay, now we talked about this before. Okay, this could be one molecule, and one molecule produces two molecules. Okay, or we could also say it was 1 mole combined with 1 mole and gave us 2 moles. Okay, but Gay-Lussac's law says you can actually use them as volumes also. So 1 liter combines with 1 liter and gives us 2 liters. Okay, so we now have equalities here. 1 liter of H2 is equal to 1 liter of Cl2, which is equal to 2 liters of HCl gas. As long as these things are in the gas phase, the coefficients will work. Okay, so you have equalities. You can do dimensional analysis. You can change liters of H2 straight into liters of Cl2 just using this equality right here. You don't have to do a whole thing where we go liters, moles to moles, to back to liters again. Okay, and note, the volumes do not have to be conserved, just like when you balance coefficients. Just because 1 and 1 gives you 2 doesn't mean that it always works out that way. Okay, next thing we look at, Avogadro's Law. Okay, remember, Avogadro was the guy who was credited with the idea that 1 mole was equal to 6.022 times 10 to the 23rd particles, or things. Okay, now, he didn't actually discover that number. Why did they name it in his name? Because of this law. Okay, so Avogadro's law says if you have samples of gases that are at the same temperature and pressure, if they have equal volumes, they contain equal numbers of molecules. Okay, and it doesn't matter what the gases are. As long as there is equal volumes, they have the same number of molecules in them if they're at same temperatures and pressures. Okay, so this translates into this law. V1 over N1 is going to be equal to V2 over N2, okay, provided T and P are equal to each other. Okay, now, what does that mean? Well, if you have 22.4 liters of any gas at STP, okay, don't forget this equality. If you are at STP, 22.4 liters is equal to 1 mole of the gas. So, doesn't matter what the gases are. If you have several gases at 22.4 liters and they're at standard temperature and pressure, all of those gases contain 6.022 times 10 to the 23rd particles, which is 1 mole. Okay, now we can also use this for the combined gas law. Remember before, the combined gas law was P1V1 over T1 was equal to P2V2 over T2 when moles are constant. Okay, but what happens if you actually change the number of moles from one gas and you change volume, temperatures, and pressures? Well, we can actually put moles back into the combined gas law. So the combined gas law now looks like this. P1V1 over N1 T1 is equal to P2V2 over N2 T2. Okay, and now this is your combined gas law. Okay, and you can use this to find all the other gas laws, provided you remember what is constant. Okay, so Boyle's law, what was constant? N was constant, and temperature was constant. Okay, so you can factor those out and you get Boyle's law. Charles's law. Charles's law, what's constant? N is constant again. And pressure was constant. Okay, don't forget, Charles's law was the one where we used the balloon for constant pressure, expandable container. Okay, Gay-Lussac's law, what was constant? Moles were constant again, and volume was constant, a rigid-sided container. Okay. Let's see, who else did we have? Avogadro's law. Okay. Avogadro's law said, hey, keep temperature and pressure constant. Factor those out, and then you come up with Avogadro's law. Okay, so from this one law right here, you can get everything else. Okay, and now don't forget, if you forget how to get this, PV is equal to nRT. Okay, and R is equal to PV over NT. So note, PV over NT, PV over NT. Why is P1 V1 over N1 T1 equal to P2 V2 over N2 T2? Because both of these are equal to R. Okay, now, stoichiometry for gases. Okay, remember, coefficients can stand for moles, particles, and now, if it's a gas, it can stand for liters, or milliliters, or cubic centimeters, or any volume unit, provided that the temperature and the pressure or the reaction stays constant. It doesn't have to be at STP. Okay, so for our reaction, A moles of X plus B moles of Y gives you C moles of Z plus D moles of Q. Okay, so going back to stuff from last semester. Moles of X, you know, can be changed into moles of anything else in here, just using your equalities, your coefficients. Okay. Moles of X can also go to grams of X and particles of X. And now, since these are gases, you can also change them into liters of X. Okay, but remember, if you are at liters of X and you want to get to liters of Y, you don't have to go from liters of X to moles of X to moles of Y to liters of Y. We can go straight from liters of X to liters of Y. Okay, don't forget this little shortcut here. You can change volume into volume of anything else. Okay, provided they're all gases. So, for your review, gas A and B at the same temperatures and pressures. Gas A has a volume of 15 liters and gas B has a volume of 30 liters. Which gas has the larger mass?